Hey, it's Clay. Welcome to another video. Today is going to be part 4 in my high voltage tube-driven overdrive pedal build shenanigans. I've done quite a lot of work. It's actually been about 3 weeks, almost a month since my last video update. I've been hard at work doing lots of things. And so I think the way I want to present this is as follows. I want to walk my way through some of the different circuits I've tried, the changes that I've been making, and do a little bit of tone clippage to kind of show why that particular part of the circuit either worked or didn't work. And then we'll kind of get a lay of the land. This has been a really fun project, but I'm also getting to a point where I kind of want to wrap it up and kind of come to some semblance of closure. Certainly the tinkerer in me would like to tinker with this forever, but let's kind of get into it. And I can't guarantee there won't be more episodes in the future, but for now I would like to bring it to some element of closure. So let's pick it up. Okay, so I've got the schematic up here on the screen, and what I was really aiming for here was to add a bass control. I previously had used this cathode bypass cap to put it on a switch to get a lower value, which would tighten some bass here on this input stage. And that worked okay, but I wouldn't say I was super thrilled. It kind of was a on or off type thing, and it was okay. It gives a little bit of adjustment, but I was looking for something a little bit more robust. So I started looking at bass circuits, and I was looking at two sources in particular. One of them was Merlin Blenco's How to Design Tube Guitar-Driven Preamps, and I found this bass circuit. This is pretty much inspired heavily by the James or Baxendale type tone stack, and so I used that for this situation. And I put it here in the middle of the two gain stages. So the idea is the signal comes in here, it gets boosted. So this is really, this first 12AX7 gain stage is acting as a heavy clean boost circuit. And then I'm using this bass control and the gain control in combination. So the bass is going to give a little bit of tightening to the low end. And then the gain is going to be kind of a volume control, a pure level control here to determine how much of this boost hits into the second gain stage to generate distortion. That was my first attempt. I went ahead and implemented this control. And to be honest, it lasted about 5 minutes because I soldered it all up. I was quite thrilled. I powered it on. I turned it on. I start playing, and it just was not responding the way that I wanted. I felt like I was hearing a little bit of low-end tightening, but it was all happening like below 100 hertz. And I just needed it to like move up a little bit higher to maybe 150 or 200 hertz. But it just wasn't doing it. It was subtle. It was very subtle. It wasn't really any better or different than this guy. And so, to be honest, I didn't even record any tone clips because I was just so disappointed. Now, I was a little bit dissatisfied with this first attempt, and my theory on what's happening is a combination of two things. Number one, this is a high impedance load. It comes at about 38K to drive into this bass control. So it's going to apply a little bit of a load on the tone stack here. But the bigger issue, I think, was because the signal that comes out of here is pretty clean still. It's boosted, but it's clean. And then you dump some of that bass to ground, and then it moves on, and this is where it starts to get clipped. And so because the clipping is occurring after the bass control, some of those frequencies were getting generated again through the clipping and the distortion here of this second gain stage. So that's my working theory at this point. And some of it may have been the levels that I chose for these components. There could have been kind of a couple different reasons for it. But overall, just wasn't super thrilled. So I went to this second type of tone stack. This one was taken from Rob Robinette's website. And the idea here was a little bit of a different type of filter being used, seeing if maybe that previous one, because it was meant more for the James tone stack, and with the James or the Baxendale, the idea there is to actually balance the levels between bass and treble. So by just using the bass, I think it was getting a little bit imbalanced. And so with this control, this is less of the Baxendale type stack, and it's more of just a high pass filter. And so I tried this one. Let's kind of see how that played out for me. All right, testing my bass control, which is this one. It's wired right now actually is kind of a thin control, so maximum bass is actually like this. So full frequency is if the tone is up like this and the bass is all the way down, that sounds like this. The tone control is pretty obvious, it rolls down treble. The bass control is a little more subtle. I'm going to leave the tone off because then you really hear it more clearly. So what I have right now is a 1 mega ohm pot, and bridged across it is a 250 picofarad cap. I'd like it actually to be a little bit even more responsive, like more bass cut, and it would be nice if the maximum bass was this opposite setting. So I'm going to rewire it for that, and hopefully that'll fix it. Okay, I swapped the capacitor on this bass control for a 100 picofarads. So I should have more bass cut. So let's start with full treble, full bass. You can hear it tightens up the low end. Okay, so I don't know what your impressions were from that clip, but when I listened to it, I again was disappointed. Even when I bumped it up to the 100 picofarads, I could tell it made a difference. It trimmed more bass, but it was trimming bass, but it kind of wasn't at the same time. I don't know how to describe it, other than to say it wasn't doing what my mind's ear is wishing for. And so I spent the rest of the day kind of researching and reading forum posts about tone stacks and bass controls, and there's a couple things. One topic I'm not really going to get into is related to impedance, but basically with this tone stack, I'm driving it right off of the plate of this 12AX7, and that's not great for impedance because the signal from the plate is not real great at driving through this tone stack, and so that's one issue to deal with. But my current theory that I want to explore is not so much plate-driven tone stacks and like you could try to put in some kind of cathode follower, or you could try to get a solid-state buffer type of a circuit that would make it low impedance to drive the tone stack better. However, what I instead want to explore is the location of the tone stack. And I think this is actually a very interesting topic, so I'm very curious to see how this experiment goes. But this is my theory, my hypothesis. And to explain it, I got to pull up some images. So this is from a post I made on Reddit years ago. What I did was I took a sine wave generator and I just made a C note, which I think was like 260 hertz. And then I get this Voxengo span, which is a frequency analyzer. And you can see when you just play the sine wave, it just makes a perfect 260 hertz tone. Next, after the frequency or the sine wave generator, I activated a guitar amplifier plugin, which simulated a Fender like deluxe reverb type of amp. And what you can see here is that the tube amp will clip the signal and cause some harmonic distortion. Now, harmonic distortion, basically harmony means we're generating these harmonic nodes. You know, you think of a choir singing harmonies. You got your bass, your tenor, your alto, your soprano. We have multiple voices layering multiple tones. Well, you started with your 260 hertz, but now you are harmonic distortioning it. And by distorting the signal, you generate these additional pitches out of nowhere. These pitches are not being played by the source material. They're being generated because the signal is being clipped through some tubes. Next, I tried a Marshall Plexi, and I cranked the gain up so it'd be a real crunchy kind of medium to high gain tone. And you can see the harmonic distortion gets like turned up to 12, and some of these nodes are getting pretty close. They're within about 3 to 6 decibels of the original tone. So there's quite a lot of generation going on. Now, this was with guitar plugins, and so it may or may not have been accurate, but I don't really get into that. I think the general science here is accurate. And what we can apply with our situation, I haven't totally thought this through because some of this is related to, this is really just happening in the treble frequencies above what we're dealing with. So I don't fully understand that. However, my hypothesis is when our signal comes in, it gets into this first tube, and it's maybe like this, and then it gets amplified, and at this stage of the circuit, the phase gets flipped, but it gets bigger. It's boosted. Well, then maybe we trim some of the bass, but then it goes into this circuit right here, this tube right here, and then it's like, it's actually more, I would say it's doing this. Not quite a total square wave, but the clipping is happening. These edges are getting clipped off because this tube can only amplify so much. There's only so much energy available. And when it clips, the signal is being changed and modified in all kinds of ways. And I'm playing not just a simple 260 hertz tone, but I'm playing guitar chords, which have multiple tones, which are generating multiple layers of harmonics. And it's just like drastically changing the tone from the input, which is what you want. That's why you have this as a pedal. But what that means is a lot of the work that was done here in the intermediary is kind of getting like undone, or like the frequencies were trimmed here, but they're getting added back in over here. And so it just isn't a super effective location for what I'm trying to accomplish. So what I'm thinking about doing is getting rid of this circuit in here, just running this into the gain control like I had before. But then instead of just having a treble or a tone control here, on this area, I'm going to also add a bass control. So we're going to shift the bass control here towards the output. Now again, I want to revisit the impedance discussion. It probably would be ideal to have a low impedance driver into the full tone stack, is basically what we're going to have, a treble bass tone stack and a level. However, because I'm using this as a guitar pedal, I think I have some headroom to spare, meaning I've got plenty of play here on the level control that I'm not really using. So even if I have a little bit of insertion loss, I think it's going to be okay if I can gain the ability to more effectively trim the frequencies that I want to trim in my mind's ear. So let's brainstorm what that's going to look like a second. All right, this is going to be the schematic I'm going to test at this time. I've no longer have the switch on the cathode bypass cap, and I've moved this variable bass control from the middle of the circuit now here to the edge. So we've got both. Your signal comes in, it gets boosted by this first gain stage. Got our gain pot to set the amount of distortion overdriving into the second gain stage, a decoupling cap, and then our bass control and treble control is kind of serving as a miniature, kind of a crude, rudimentary little tone stack here. Now, I haven't really seen this tone stack with the bass and treble like this before. Again, this bass came from Rob Arbonnett's website, and this treble came from some of the schematics I found online. It's just a simple high-end roll-off. So I don't know if this is how you would want to do it in theory or in practice, but we're going to see how this sounds just because I've already got the pots wired up like this. So I really just took the bass pot from here and moved it here to the outside. Let's hear it. Now the bass. All right, so with this current tone stack, my feel on the performance is still a little bit disappointed. The treble control is working fantastically well, but the bass control is not working great. It's definitely doing something to the sound, but it almost kind of sounds like a low mid-range scoop as opposed to a high-pass filter. I think you can hear that in the clips. So I'm going to take another shot at it. Now, I'm not 100% sure if I'm following exactly what's going on, but my working theory is that either this decoupling cap is messing with the bass circuit, or the location of it as it regards to this treble path to ground or the level path to ground. Something is messing around with it, and I'm not 100% sure what, causing it to not work right. So I was doing some reading around, and I've kind of been intrigued. I've known about this, either a James or a Baxendale type tone stack. And I was reading this article here on ampbugs.com. You should check it out. This is a good website. And this is one where he wants to build his own circuit, and he walks through all of the calculations you'd make to set the filters at different spots. This is really, really good stuff. But you can see here these design goals. They want to set an 8 decibel mid-range attenuation and max control settings. And with the Baxendale, in case you aren't aware, it's got a bass control and a treble control, and then the mid-range is kind of fixed so that you can kind of go up and down relative to that fixed mid-range. And so that's a good starting point to me. And then setting the bass to mid-range transition at 500 hertz. So you're definitely going to be feeling the bass attenuation if it goes up to 500 hertz at maximum cut. And the mid-range to treble transition at 1K. Again, you're going to feel that. So I feel like those were just some good general parameters. And so at the bottom of this article, it gives a circuit right here. So I took this circuit, as best I'm able to understand it, and plugged it into this tone stack calculator. And with this one, so first of all, and the nice thing about this is you're able to set your RN, which is your input impedance. Because this is coming off of a plate, it's going to be a 40K input impedance, which is relatively high. You would prefer to have a lower input impedance coming from like a cathode follower, but I don't have that right now. And in order to add a cathode follower to drive the tone stack, I'd either need to add another tube or I need to add some kind of solid-state buffer circuit, which would be doable, but I'm not really super interested in that. I'm curious how this will sound. Also, if we go back here, if we do have a little bit of insertion loss in my level, my overall output level comes down a little bit. I'm okay with that because so far I've noticed I have quite a bit of level on tap. So we're going to try it. Now, what I'm watching here is, first of all, the sweep of this bass control. And I think what you notice here is, we're definitely starting to see some attenuation at minimum settings. I mean, this is going to feel very, 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 very lean in the bass, very tight, high end, a lot of high end, a lot of shrillness. And that is not a sound that's currently in the pedal, so I want that. And then at the medium setting, with both of these, it still is pretty flat. Now, there is about 18 decibels of overall insertion loss, so there is definitely some loss going on here compared to it as stock. But one thing I might try to do is maybe put it on a switch so I could bypass the tone stack entirely for more of a raw feel if that's what you would prefer. So it's just some options I'm kicking around. But then if we look at sweeping the treble control, you can see it also does a pretty nice job of sweeping some of these treble frequencies, especially in this kind of between 1 and 10K range. So yeah, you have the ability to have more of a mid-scooped tone, which is not in the pedal as it is right now. You can have more of a mid-range push sound, and then also more of a flatter sound. And with everything in between, a lot of treble or a lot of bass. And so I feel like this tone stack is going to give the pedal a lot more flexibility. And so I've put it into the schematic here. And this is what I'm going to try to implement right now. So let's go ahead and put that in the pedal and see how it goes. I got the new James tone stack wired up. I was kind of having a hard time figuring out how to do this on the pots or on my open terminals, which was kind of random throughout the board. So instead what I did is I had this little, circuit board, and I decided to just kind of wire it all up on there. The other problem I ran into is I ran out of 470 picofarad caps, so I'm using two 1000 picofarad caps in series to drop the capacitance in half to 500 picofarads. and I think it's going to be fine. So yeah, just going to once over the wiring. It's turning into a bit of a spaghetti nest, and I'm going to have to mount this thing probably in this area. But yeah, I think it's going to work. This is the James style treble and bass controls, and I've tried it for like 5 minutes and I hate it. Bass, treble. I think the issue here is it's just not very like well balanced. I don't know. It kind of does this weird scoopy thing. It has a fixed mid range, and here's the treble. The treble should be able to go up and down relative to the mid range, and the same thing with the bass, should be able to go up and down. So if at max with the knobs like this, you should be able to get a little bit of a smiley curve, and then with the knobs like this, you should be able to get to a frowny curve. But I don't know, they're just not balancing very well. I'm not able. I think it's possible if I ordered a whole bunch of specific values of capacitors and pots and pots with different tapers and different values that I could find what I'm looking for with this, balance it out, but I'm just not into it. I think what I would prefer is something simpler that's just a high pass and low pass filter. So my next iteration was to kind of try to take all the things that I've learned and make some adjustments. And number one is now I'm trying to focus on trimming the bass and treble frequencies. So again, if this is our frequency, I'm trying to kind of get a little bit of a high pass filter with the bass and a little bit of a low pass filter with the treble, and keep the mid range peaking up. And so I shifted things, and instead of the typical decoupling cap I was using, I used a much smaller value decoupling cap that would be intended to be used in conjunction here with the bass pot. So this is basically just a pure high-pass filter, a capacitor resistor to ground filter. And that runs in series then into a resistor capacitor high-pass filter, or low-pass filter. So these two components here are shifting, where the high pass is located. Hopefully, as you turn the bass up, this point moves this way, so it look more like this. Then, on the flip side, this treble control, is going to be moving the low pass filter this way. So that was the theory. Let's kind of see how that played out. All right, this is my high pass, low pass version 1. I've gotten a little bit unhinged, and so I did the whole thing on a breadboard, kind of. bass control. And now, kind of things have come a little bit full circle. Again, just was not real satisfied with how that whole thing was proceeding. So I went back to the version of the pedal that I was most happiest with and tried to just kind of polish that element of the circuit, which means we go back to the bass switch and we go back to the treble control here at the end. And I actually, this is where I have settled. And I think at this point, I'm willing to say I'm quite satisfied with how the pedal is operating and sounding. But I did make some subtle changes. Number one, got a little bit of a lower value decoupling cap here, and I changed these values. So my fat full frequency cap is it's 2.2 microfarads. I also maybe tried a 4.7 microfarad, but that's, you could go all the way as something as big as a 25 microfarads. That's going to be given all kinds of bass frequencies. 2.2 UF still has a little tiny bit of bass trimming. I'm going to say somewhere between 60 and 100 hertz. And then the 0.47 is a tighter, so now we're starting to trim up to 100, 150, even 200 hertz to my ear. And I think these are just kind of balanced well with one another. You can still hear when the switch goes between the two, but it's not such a huge drastic change that it's upsetting. Then I also changed the treble to a 1 meg pot and a 250 picofarad cap, and I was pretty happy with that. That actually kind of mellowed out the treble control so it doesn't get so wicked dark when it's all the way down. This worked nicely. So let's listen to some more extended clips, and this is where I'm pretty satisfied with where the circuit came out. I think the way this is functioning is it gives me a good range of tone that I can use with a variety of guitars and still sounds really good, kind of pure to the essence of what this gain pedal does really well. So let's listen to those clips. Okay, so I hope you guys enjoyed this video. I am going to call this pedal kind of completed at this point, although there are definitely some future modifications that I'd like to try. Number one, if I was going to mess with it, I'd like to try a DC power supply. I've got some ideas about buying one of those circuit boards online and using that as the power supply. Maybe something with a little bit higher voltage too, getting up to maybe 200 or 250 volts. So that could be kind of fun. Next, I would like to consider trying a boost circuit on the input. So if I could run just maybe a JFET booster on the very beginning input to give me the possibility of really taking this thing to a much more higher singing distortion type of sound. And then, the other thing that I would think about too is if I did want to revisit some of these tone stack things, I think the way that I would do it is try to incorporate a way to have a cathode follower. Or, the downside of a cathode follower, well, let me back up. So the main idea here is I want to get a low output impedance. The plate of the tube has a 38K output impedance, which is moderate to maybe a little bit higher. If I could figure out a way to maybe insert some kind of buffer circuit, maybe a solid state buffer, a simple buffer, to drive that input impedance way down, that it could drive through the tone stack at the end of the circuit better, I think that would help those filters function better to my ear and do more of what I want them to do. And then also just, if you're going to have a tone stack, you want it to drive efficiently. So that really would be the optimal way to do it. So, having the boost on the input and then the cathode follower, the buffer or whatever on the output would be kind of nice. All that to say, I could also do those two things with another 12AX7. We could put another 12AX7 stage on the front end, and then we could put another 12AX7 stage on the back end using the cathode follower. So I have, could just put a second tube in this thing while I'm at it. So still plenty of room to tinker with this. But for now, I'm going to call this thing good. I would love to hear your feedback down below. The last thing I want to say, one of my goals here as well, is I'm going to try to take some steps towards refining this schematic and possibly getting this thing onto a PCB. So if you'd be curious about ordering a PCB that you could integrate into a build like this, please let me know down in the comment section below. I hope you guys enjoyed this video as much as I have. This has been a really fun series, and at the end of the day, I'm pretty thrilled with having this prototype pedal, and I'm excited to revisit this concept again in the future and maybe get this thing out so that other people can play it and get some feedback and continue to refine it from there. So love to hear your thoughts down below. See you guys again soon. Thanks. Bye.